How many squares are there on a chessboard? Or how many squares are there in this 1000 by 1000 grid? So we're going to answer that question. We're going to make a sequence out of these values and call it Cn. So Cn denotes how many squares are in an n by n grid. Some easy values, C0 is 0, and C1 should be 1. Let's calculate C2. There's 1 2 by 2 square and 4 1 by 1 squares. Thus there's 5 total squares, so C2 is 5. Let's get C3. There's 1 3 by 3 square. There's 4 2 by 2 squares. And there's 9 1 by 1 squares. That's a total of 14 squares for C3. Let's calculate C4 so you see the pattern. There's 1 4 by 4 square, 4 3 by 3 squares, 9 2 by 2 squares, 16 1 by 1 squares. That's a total of 30 squares, so C4 is 30. Now let's calculate how many squares are there on a chessboard, C8. And the pattern tells us to start with our 8 by 8 square, and there's one of them, and we continue adding squared numbers until we get to how many 1 by 1 squares there are, which are 64. That's a total of 204 squares. We're going to write that pattern down we uncovered more generally here. So Cn is 1 squared plus 2 squared all the way up through n squared. What we'll now do is obtain a nicer formula for Cn using a technique called polynomial fitting. So observe the first 5 values of Cn that we've calculated, and I threw C5 as 55 on at the end, and it'll help calculate the first differences, subtract consecutive terms. From there, we'll form the second differences of the sequence. We'll subtract the consecutive first differences. And finally, we'll look at the third differences. We notice that these are constant. A theorem says that any sequence whose kth differences are constant is given by a polynomial of degree k in the variable n. So for our problem, k is 3, and we seek a degree 3 polynomial that looks like this. So we need to find these constants a3, a2, a1, and a0. To do that, we're going to utilize the first 4 values of Cn that we know. We're going to make a system of equations. So when we substitute these into that polynomial expression, we obtain these 4 linear equations in a3, a2, a1, and a0. And what we'll do is we'll use elimination and substitution, these techniques from a college algebra class, in order to try to solve for a3, a2, a1, and a0. We're going to eliminate a3 from 2 sets of equations. It yields 2 equations that involve only a2 and a1. From there, we'll eliminate a1, so we get a single equation only involving a2 that we can figure out what a2 is. So a2 must be a half. We'll take that value, a2 is a half, and we'll substitute it into a2 so that we can obtain what a1 is. When we do the algebra here, we obtain that a1 has to be 1/6, and we substitute these 2 values in to finally obtain a3. So a3 is 1/3. Thus we found our coefficients to obtain a nicer formula for the number of squares on an n by n grid is this cubic polynomial. Next, what we'll do is we'll use this easy formula to figure out how many squares are on a 1000 by 1000 grid. We'll substitute 1000 in. So C1000 should be 333,833,500 total squares. Thank you for watching.